A very lovely hello to all NEET 2026 champions once again in fabulous live class of physics. So my dear champion, first of all let me know as you all can hear me, I'm audible to you everyone and everything is fixed. There is no any technical problem, you all can hear me and I'm audible to everyone. Please let me know so that we can start the session without any delay. Let's join quickly. And in today's class, we are going to solve quality PYQs, I mean complete electrostatics. Yes, so I have brought up some very good important question that may be probably very helpful for you all in upcoming NEET exam that is on 3rd of May. So let's join quickly, all everyone. Join fast. Everything clear, very good. Hi Nagu, Sneha, hi Sneha, not audible? Oh. Sorry guys, it's so, look, it's so funny. I was not using my mic and I was asking from you all, am I audible to you? So, ready, very good. So let me use my mic. Now audible guys? Sneha, now audible? Ready sir, very good. Now audible, everything is fixed? Please let me know everyone, everything is fixed? Yes, champion. Audible sir, very good. Okay, so let's wait a little while for other students so that they all can join and can get advantage of this fantastic session of electrostatics. 100%, very good. Wait a little while for others, those who have been studying on this channel, on my live classes. Basically I'm looking for all the students and they might have been waiting for a long time, and yeah, your wait is over. And yes, tell me one thing everyone, I hope you all got your admit card, because your admit card is officially released by NTA yesterday. So I hope you all have got your admit card, and so that you all can make your prior arrangement to reach your examination center comfortably. Now today is 27th of April and 3rd May is your exam. So hardly almost 5-6 days are left, champions. So this is the right time to just revise just only formulas. Don't try to study anything new in physics. Okay, just go through the formulas and just try to solve as much as possible only PYQs. Okay, so let's begin the session. So starting with question number 1, and that is from previous year 2025 question paper of NEET. Look at the question. Who is this? Okay, yes, so two identical charged conducting spheres A and B have their centers separated by a certain distance. Very good. Charge on each sphere is Q and the force of repulsion between them is capital F. Means both the charges of same polarity, whether they might be positive or they might be negative, both. So the force of repulsive force will be there. So the first condition here is there are two charges, sphere A and sphere B. So let me give you the solution. Let's solve here. Solution. So, my dear champion, initially there are two spheres, A and B, right? And both the spheres are having charge small q. So, this is small q and it is also having small q, and the distance between both the spheres are small r. So, what will be the force? Force acting will be equal to K Q1 Q2, which will be Q square and divided by R square. This is your first situation. Now is it clear? The force of repulsion. So we have solved from here to here and this is the result. Now moving ahead, a third identical uncharged conducting sphere, the shape, the material of sphere, everything is same, because identical sphere we are talking about, but the charge, the third charge that we are bringing having no charge, that is uncharged body. So you all know when this third charge will come contact with this charged body, so a third charge identical uncharged conducting sphere is brought in contact with the sphere A. So what will happen? So the second situation is charge A is already there having Q charge. Now the third charge, the third sphere, which is, let's say C, has came in contact with this. So what will happen if this, it has charge Q? So now the charge will be distributed, and you all know how the charge get distributed equally. If this is uncharged body and this A sphere is having charge Q, so after charge distribution, after charge distribution, you all know the charge distribution will be average. So A will be look like Q by T, and the C charge will also look like Q by T, because this was uncharged and it has came in contact with A, so the charge polarity on A and C will be Q by 2, Q by 2. This is the second situation. Now look at the situation. Okay, and then B. So the third charge came in contact with A, and after coming in contact with A, the C is having charge Q by 2. Now in third condition, this Q by 2 charge came in contact with, means C charge has came in contact with B charge. So what will happen? This is B, and B is already having Q charge. Q charge is there. This is Q charge, right? This is Q charge. Now the C charge, which is having Q by 2, is coming in contact with this B charge, B sphere. So what will happen? After charge distribution, both the spheres will having average of the charge. So this A will be this, and here the C will be this. So can we find out the average Q plus Q by 2? So this will be 3Q by 2, and this will also having 3Q by 2. So this, can you see here? This is Q and Q. So Q by 2 plus Q by 2 divided by 2. So that will be, this will be average. Come on, can you see here? Average of both the charges. So this will be like this. Can you see here? Average. So Q plus Q by 2 divided by 2. So this will be 3Q by 4. So now after charge distribution, A is having 3Q by 4 and C is also having 3Q by 4. Now the question is asking what will be the force acting them. Now this is new force of repulsion between sphere A and B will be what? So can you see here? The A sphere A is having only this Q by 2 charge finally, and C is having final charge 3Q by 4. So now we can find out the force of repulsion F dash. Let's say this is F dash. So this will be K into Q1. It means Q by 2 into 3Q by 4, and R square separation is again same. So this will be F dash, and this will become K into Q square divided by R square, and this Q by 2, and this is 1 by 2 and 3 by 4. This will become 3 by 8, and this is KQ square by R square is nothing but capital F. So now we can put here F dash is equal to what, my dear champion? 3 by 8F. This is the answer. Any option is there? Option number B will be the correct answer. So this was very easy question. It was a bit lengthy, but very easy question. Yes, any problem to anyone, champion? So this was based on the concept of charge distribution, and we all know how charge get distributed. Charge get distributed as the average of the charge, right? So first, this was the initial condition when both the spheres had small q charges and separated by this. When the C sphere, which is uncharged, came in contact with A, so after coming in contact with A, now this is the scenario. A is having Q by 2 and this is having Q by 2. How we can find out the net charge distribution? So that is the average. So Q plus 0 divided by 2. Q, and here is no charge, so Q plus 0 divided by, so that will be Q by 2, right? Now in third situation, now C sphere which is having now charge q by 2. Now C sphere has came in contact with B, and B had already q charge. So when C is coming, q by 2 is coming in contact with B. So what will be the average charge? So q plus q by 2 divided by, so that will be 3q by 4, which is now 3q by 4 and 3q by 4. Now we have to find out the force acting between A and C. This was the question. I hope everything is clear to you all. So option number B will be the correct answer. Please keep it in mind, when an uncharged body comes in contact with charged body, how the charge distributes? The charge distributes in the form of average value of the charge. Let me show you. Listen, champion. Let's say there is a spherical body and which is having 4 Coulomb charge, right? And I'm bringing one more sphere here which is uncharged. No charge is there. It means 0 charge is there. 0 Coulomb is there. So when this charge will come in contact with this, what will be the final scenario? The final scenario will be 2 Coulomb and 2 Coulomb. The charge will get distributed in average form. So here will be 2 Coulomb and here will be 2 Coulomb, right? Because 4 is 4 plus 0. So when we find out the average, 4 plus 0 divided by 2, that will be 2 Coulomb charge. So this is the scene here. This is the scenario here, right? So when two charged body or uncharged body comes in contact with each other, so charge gets distributed in as, so that they can go through, they can set up as equilibrium condition. And the equilibrium condition is what, my dear champion? The equal charge on both the bodies should be there. Okay, moving to next question. Yes, who can solve this question? Who can give me correct answer for this question? Yes, a lot of students are watching the class here. Tell me, my dear champion, which option will be correct here? Let me give you a shortcut example, a shortcut solution for this question. So can you see here, one diagram is given there. And on the basis of this diagram, we have to find out electric potential. And do you know, all the champions, electric potential means, we all know this is scalar quantity, scalar value. Electric potential never required vector resolution because this is a scalar quantity. We can directly add algebraically because a scalar quantity is there. Now, what we have to find here? At point P, we have to find out here the electric potential at point P. Can you see here? That is the point P. So at this point, the potential due to minus Q will be there and potential due to plus Q will be there. So V net here, V net is basically is equal to V due to positive charge plus V due to negative charge. This is the formula that is we are going to use here in this question. V positive Q high. Sayyada Sara. Hi Sara. So here in this question we have to find out electric potential, and can you see this is from year 2023 PYQ, very important PYQ from NEET 2023. So we cannot ignore, we should not ignore such questions, right? So in this question we want to find out electric potential, and you all know electric potential is a scalar quantity, so no vector resolution is required. You directly add, you can directly apply the formula and you can add the values. So let's do the question. So electric potential, we have formula KQ by R. This is the formula for electric potential. And we need to find out V net here. V due to positive charge and V due to negative charge. So what will be V due to positive charge? Let's find out V due to positive charge. So first find out V due to positive charge. This is V due to positive charge. So the formula will be K, and positive charge means positive charge divided by R. If we are treating with positive charge, so distance of positive charge will be taken at the position where you are finding out the potential. So P is the position where we are calculating the potential. So what will be the distance? This point, can you see here? This point, this P point. So this distance will be considered, and this complete is 5 centimeter from center, and this is the 3 centimeter. So this will become 2 centimeter. I hope you are getting my point. 2 centimeter will be there. Now we can put the values here. So this will become 2 centimeter. Come on, can you see 2 centimeter? So we have to put here 2 into 10 to power minus 2. Why? Because the distance is given in centimeter. Right, champions? So can we write here this format again as KQ divided by 2 into 10 to power 2, and just keep it as it is, equation number 1. Now similarly find out potential due to negative charge. Can you see here the potential due to negative charge? Again apply same formula. So potential due to negative charge will be K, and Q will be taken as negative because In potential or in potential energy, we consider sign also. In electric field, we never consider sign. But in potential, we have to consider the sign also. So V negative charge, and for negative charge, this will be the distance from P. So this is already, this is 3, and from center, this is 5 centimeter. So 5 plus 3 will be 8 centimeter. So can we write here KQ by 8 into 10 to power minus 2. Why I am writing 10 to power minus 2? Because, my dear champion, distances are given in centimeter, right? So this is the second, can we please modify this? So minus K Q divided by 8 into 10 to power 2. This is the second. So what will be the V net? V net, can we please add? And let's take common KQ, and KQ into 10 to power 2 common. So can we solve here? So 1 by 2, this is 1 by 2, this is 1 by 2, and this is minus 1 by 8. So 1 by 2 minus 1 by 8. Now solve this. So by solving this KQ into 10 to square, can we solve this? 8, so 2 4 ja 8, 4 minus 1, so this will become 3 by 8 KQ into 10 to power 2. This is the answer. Any option is there? KQ, and we can write, see my dear champion, can you see here, this is KQ only, and if we want to replace this by 1 by 4 pi epsilon naught, we can replace this. How? Listen champion, we can write this 8 as this 8. Can you see here? This 8, this is KQ. So this 8 can be written as, let me give you the solution correctly here. I hope till here no problem is there to anyone. This K is given here. Can you see here? 10 to power 2 volt at a point P due to dipole. E is the permittivity of free space, and 1 by 4 pi epsilon naught is basically K, and we have already written here K in the form of K. So this is equal to 3 by 8 KQ, and we can ignore this value, so this will be the option number C will be the correct answer here. 3 by 8 KQ will be the correct answer. I hope this is clear to you all. Please give me response here in chat section. Yes sir. Hi Vinay. Is it clear to all, everyone? Hi everyone. Yes, lot of students are watching the session. Please tell me if any doubt is there. Please tell me. I can repeat the solution again for you. Hi Sayyada. Hi everyone. Sneha, Vinay. Any problem to anyone? Please let me know. If you are having any kind of issue, any problem, please let me know. I can repeat the solution again and again for you all, champions. Yes, any problem to anyone? Please let me know. I'm waiting for your response. Very easy question. So when you're solving potential means electric potential means scalar quantity. So electric potential never required, electric potential is scalar quantity, right? So we can directly add scalar quantity. So no vector resolution will be there. We don't require to solve this by vector. No. Directly add. You can directly add algebraically. So by putting the value, but make sure if centimeter is there, always make sure, always convert the centimeter into meter. So this 3 centimeter, or I can write here, centimeter always convert in meter, champion. And you all know we have to multiply by 10 to power minus 2. Now, if you want to convert centimeter square to meter square, so we have to multiply by 10 to power minus 2 whole square. It means that 10 to power minus 4. If you want to convert centimeter cube into meter cube, sometime in volume, sometime we required in physics. So multiply 10 to power minus 2, and as you all know, cube is there, so we have to put here cube. So this is all about. Please make sure to use conversion of units in centimeter to meter always in exam in this form. So I hope you got the answer. Moving to next question. Electric field at center O of semicircle of radius A. Very good. So there is a semicircle having linear charge density lambda. Very good. The linear charge density is given here. You know linear charge density? The charge distribution per unit length. Charge distribution per unit length. So we can also write dq is equal to lambda dl. So this is called linear charge density, the charge distribution per unit length. Now, can you see here? We have to find out here electric field. So listen my dear champion, I can solve this question by so many methods, but as you all are appearing in your NEET exam, and this is not the right time to give you, you know, a very detailed approach, very detailed solution, very lengthy solution. You all required shortcut method, because ultimately marks, the motto is to gain the marks, to get the +4 marks. Ultimately the target of every student is to get the marks, right? So I'm going to give you a very short formula to calculate such question. I'm waiting just for a little while, 1 to 2 minutes for all the students. Anyone from you can give me correct answer for this question. Where is the question? Yeah, question number this. I'm waiting for you all. I want to see the name of the student who can solve this question. Do this, come on, champion. Hi everyone. Yes, Vinay, Varalakshmi. Yes, try it at least once, please. Try it. Come on. Everyone can do this question easily. Try it. Come on, once. Hi. No, sir. At least try. You should try. Which option will be correct here? C. Abdul Rashid is giving option number C. Okay. Abdul Rashid is giving option number C is correct, sir. Okay. Just a second. Option number A. Sylvie is writing option number A. Okay. Lot of confusion. Okay. Yes. Anyone else? Anyone else? Okay, so listen, champion, I'm going to give you a very shortcut formula, very powerful formula to solve this question. Listen, this question is from the year 2000. Okay, electric field at center O of semicircle of radius R having linear charge density. It means that this semicircle is a charged body. This is a charged body. Hi sir, I scored 110 in KCET and 95 in board. My engineering. Shankar, I'll be giving you about answer of this question that you want rank on this score. You are getting 110 in KCET. That's a good score, I think. Yeah, just wait a little while. I'll be talking to you on this topic. Okay, listen. So this semicircle is charged semicircle and the charge density is lambda. And we want to calculate the electric field at this point here. So very easy shortcut formula to solve such question is, you guys can directly use this formula, 2k lambda divided by r sine theta by 2. Oh my god. Now you might be thinking, sir, where is sine theta by 2? Listen, champion, if you start from this point and go here at this point, so this complete semicircle will go in this format. So how much angle this is forming? That is equal to 180 degrees. So that is basically theta, the angle which is making complete semicircle. Getting my point? So directly use this formula, you can get the answer. Can you please check it in? Dekho, listen, this is 2k lambda is the charge density, and radius, where is the radius? Radius is this, and here in this question the radius is small a, so we can put here a small a sine, and theta will be this theta complete 180 divided by 2. So what will be the result? E 2k lambda, and 180 divided by 2 will be 90, and sine 90 is equal to 1. Oh my god, 2k lambda by a. You may be thinking, sir, where is no option is there? Have patience. You know the value of k, put that value. So E is equal to 2 into 1 by 4 pi epsilon naught into lambda divided by a. So can we please cancel this? Oh wow. So answer is in front of you, lambda divided by 2 epsilon naught, 2 pi epsilon naught a. This is the answer. Any option is there? Lambda divided by 2. Wow. Option number C will be correct. So very powerful formula, very important formula, champion. Please keep this formula in mind. Just in 3 lines you can get your answer. And can you see, this question is from the year 2000. Just in 3 lines you can get your answer. Yes, Yes. 295 marks in both, so what is your percentage? Can you please calculate the percentage? Just let me know the percentage. Let me know. Okay. Yes, is it clear to everyone? So my dear all future doctors, all NEET aspirants, please keep this formula in mind. This question will be helping you out a lot in solving such questions. When circle is there which is charged, semicircle is there which is charged, and the charge density will be given to you, everyone. Yes, tell me, any problem to anyone? Yes. Yes, any problem to anyone? So to solve such questions, always use this formula, and this is very shortcut formula for all NEET students. Shortcut, this is the shortcut. Otherwise, some student will be taking 5 to 10 minutes in solving this question by taking the angle here, angle, small angle, like small angle d theta, and after taking electric field component. So you know the long mathematical procedure is there. I think you should not follow that. Just keep this formula in your mind. Moving to next question. Okay. Yes. Okay. Look at the question here. Okay, everyone, please look at the question. We have a lot of question to do, and we have very short time. We don't have so much of time to solve such questions. So I'll be little bit, in speed here today. We cannot utilize we cannot waste our time in different things. So we should focus on question because you don't have a lot of time now. Okay. Yes. Okay, look at the question. This question is from NEET 2021. NEET 2021. Okay. Okay. 27 drops of same size are charged. Okay, so there were 27 drops of same, drops means spherical shape, are charged at 220 volt. Okay, the potential is 220 volt. They combine to form a bigger drop. Okay, they got combined and they form a bigger drop. So what will happen? You all know in maths, when the drops are combining with each other, the volume will remain same. Okay, calculate the potential of the bigger drop. Perfect. So we have to find out here the potential of the bigger drop. You don't need to worry about, I'm here. So let's solve. So my dear champion, if 27 drops of same size are combining to form a single drop, so first we have to find out the radius of newly formed sphere. So 27 into 4 by 3 pi r cube, that will be equal to 4 by 3, and 27 drops, 4 by 3 into pi r dash cube, because we don't know what is the radius of that, so we have to put here r dash cube, right? 27 drops of same size are charged 220 and they combine to form a bigger drop. Calculate the potential of the drop. Okay, so if we cancel here, this 4 by 3 pi r, 4 by 3 pi r cancel, so we are getting here 27 into r cube, that will be equal to r dash cube. So what will be r dash? So r dash will be equal to this is 3 cube, this is 3 cube, and this is r, so we can directly write a 3r. R dash will become 3r here. R dash will become 3r here. I hope till here no problem. Is it clear? Now we have to find out the potential of the bigger drop. So what will be the potential of bigger drop? Potential we have formula kq by r, right? So potential of bigger drop will be kq divided by r is equal to 3r, and can you see here kq by r? Kq by r is the initial potential, and the initial potential was here. Can you see? Okay, do one thing here. Let me give you a shortcut method. We can solve this by shortcut method. Listen, how many drops are there, guys? 27 drops, and they all are of same size, right? And the potential of each drop, this term is very important. Potential of each drop is at what? 220 volt. This is the logic here in this question. I have already given you the radius. The radius of newly formed sphere will be 3r. So how we can find out the potential of the new bigger drop? Anyone is there who can give me correct answer for this question? Hi everyone. Anyone is here who is, you know, dedicatedly preparing for the NEET exam and who is in the race of 13-14 lakh student? Anyone can give me correct answer for this question? I'm looking at the chat section. Yes. And I have given you the concept here. Radius I have already given you. So what will be the potential of the new bigger drop? Tell me, my dear champion, if anyone can give me correct answer, it will be really impressive to see you the name. Anyone is here? I'm looking at chat section. Yes, champions. Let's solve it. 0. Yes. Come on, champion. Try it. What will be the potential of the bigger drop? 4 options are given there. And you have to find out the correct option, correct number. Tell me, please. Yes. No one is here. Which option will be correct? See, this was the main important thing in this question, and that has already proved. I have already given you the radius. Now we have to find out the potential. Who is this? Okay, no one is there. So listen. What will be the potential of the bigger drop? Oh, come on, champion. The potential of the bigger drop will be 27. Because why? Listen. The 27 drops each had 220 potential. So 220 potential is combining with to make a single sphere. So that 220 potential with each sphere will be included here. So 27 into KQ by R. Into KQ by R, potential for, I'm talking about potential of new sphere, V dash. So this will be KQ divided by R dash. Simple. So solve this. So V dash will be equal to 27 into KQ divided by, can you see here, R dash is equal to 3R. Now we can put here 3R. Right? Now after putting 3R, this 3 will cancel this 9 times. So V dash is equal to 9 into KQ divided by R, and KQ divided by R is what? Potential of each single drop, which is equal to 220. So this will be equal to 9 into 220. Can we please multiply the value what we are getting here? 9 to the 18, carry 1, 9 to the 18, 19. Oh my God, 1980 voltage is correct answer. So option number 1 will be correct here. No one responded here. No one. Lot of students are watching the session, but no one responded. Is there anyone who responded here? I need to refresh my page here. Okay. Oh my God. R27. No. Abdul Rashid, R27 will not be. R will be, yes, Abdul Rashid answer 1980. Sue answered 1980. Very good. Option number A. And other one? Okay. Superb. Very good. My laptop, I need to refresh this. Okay. Very good. 1980 will be correct answer. So my dear, these questions are very important. You should take screenshot, and if you are sitting with your notebook and pen and if you are solving here, that's very good. Yes. Is it clear to everyone? Any problem to anyone? Just let me know. If anyone is having any kind of problem, please let me know. I can repeat the solution again. I hope this is clear to you all. This was the volume, initial volume of 27 spheres. And this is what? Volume of new sphere which is formed. So volume will remain same, na? After putting this formula, we got the relationship between R, radius. Yes. Moving to next question. Question number 5, yeah. In the following circuit, the equivalent capacitance, okay, between the terminal A and B is what? So this question I missed here to show that year of the question, but yeah, this question is as I remember around 2022 or 2023. Yes, anyone is there? So we have to find out here equivalent capacitance between A and B. My dear champion, we can modify this circuit as, we can also modify this circuit as, can you see here? This circuit can also be modified as, just look at here the screen. This, oh, this is capacitor, no? Here, one capacitor, two capacitor, three capacitor, four capacitor. This we can modify this format. So here is A point and this will be point. Same circuit is there. Now can you see this is 2 microfarad? Okay, if this is 2 microfarad, this is also 2 microfarad, and if this is also 2 microfarad, and if this is also 2 microfarad, and here this is also 2 microfarad. Oh my God, just divide 2 microfarad by 2 microfarad. This is 1, 2 microfarad, 2 microfarad, this is 1. It means that this is Wheatstone bridge. This is balance condition. This is Wheatstone bridge. This is balance. Wheatstone bridge. Wheatstone bridge. And the important thing here is balanced. This is balanced. Why I am saying this is balanced? Because the ratio of this and this 2 by 2, 2 by 2, 2 by 2 is equal to 1, and here this is 2 by 2 is 1, so balanced. And if this is balanced, it means that no current will pass through this. We can ignore this. No current will pass through the common capacitor which is connected in between. No current will pass. I will be 0. Here the I will be 0. We all know the I will be 0. It means we can ignore this. The presence of this capacitor and the absence of this capacitor is no mean. So whether so better is we can ignore that. So only this will be connected. And now if we ignore this middle capacitor, this central capacitor, so these two capacitor will go in series combination, and these two will go in series combination, right? So can we find out the capacitance of equivalent capacitance of these two? So let's, I'm saying this C1. So C1, we all know we have a formula, very shortcut formula. When two capacitors are in series combination, just multiply 2 into 2 divided by, add both. So 2 to the 4 divided by 4, that will be 1 microfarad. And let's find out C2. So C2 is this series combination. For series we have formula, very important, multiply and divide. So again 4 by 4 will be 1 microfarad. Now these series and this series, they both will be in parallel. The equivalent of this and this and the equivalent of this and this will be parallel. So we all know now the C equivalent will be equal to C1 plus C2. In parallel combination we just normally add up. So 1 plus 1, 1 microfarad plus 1 microfarad, and this will be 2 microfarad. Answer, any option is there? Can you please check out any option is there? Option number A will be correct answer. 2 microfarad will be the correct answer for this question. I hope everything is clear to you all. Yes, any problem to anyone? Yes, champion. Who answered me correctly for this question? Let me check it once. Yeah, it happens, drop a random, I don't know your name, but it happens. So to rectify this problem that you're having, like when you start solving PYQ, you're stuck somewhere, you are having a lot of problem. So I think you can rectify this problem by doing practices, lot of questions, try to do lot of numericals. Don't get scared of numericals. The practice will give you the perfection, trust me. There is no shortcut in physics. Yeah, got your point. I hope this question is clear to you all. And guys, the student who haven't pressed the like button yet, go and press the like button of this live class, and make sure to share this session with your friends as well. Yes, Sue, I got, this is Wheatstone Bridge. You are writing same text again and again. Is it clear to all champions? So whenever such circuit comes up in front of you, so make sure to check out the balance situation first. Make sure to check out the balance situation, and once you get it, yeah, the circuit is balanced. It means that no current will flow through this wire. It means we can ignore this. The presence of this capacitor is making no any impact in the circuit. I'm not ignoring your answer, Sus, please, yeah. Champion, I don't know your name. No, not at all. Come on, don't think like this. Okay, moving to next question. Okay. You all are very important for me. I never ignore any of my student. One of you is important. Each one of you is important for me. So don't think like this. Okay, you all are important for me. Okay. So ABC are 3 points in a uniform electric field. The electric potential, okay. So we have to answer for electric potential, and the diagram which is given here is of electric field. Electric field is propagating from here in this direction. My dear champion, keep one thing in mind. In the direction of electric field, the electric potential decreases. Come on, please keep it in mind. In the, I'm writing here, in the direction of field, potential decreases. Please write this in your notebook, and this is not the time to write in notebook. Better is write in your mind. In the direction of field, potential decreases. And if the electric field is starting from here and it is going in this direction, so where the potential will be maximum? I have already given you, in the direction of field, potential decreases. So the potential of A will be lowest and the potential of B will be greatest. It means that potential at B will be greater than potential at C will be greater than potential at A. This is the answer. So can we please go to the option maximum at C? Oh, not possible. Same at, what they're talking about, same. Maximum at A, not at all. Maximum at B, yes. Option number D. Who answered option number D? At B, because if further potential decreases. Yes, yes, so very good. Very good. Yes, maximum at B. Please write it down, this line. In the direction of field, potential decreases. Because we have formula. If you remember that formula, E is equal to minus dV by dL. We have this formula, E is equal to minus dV by dL. E is equal to, we can also write this formula in this format, like dV is equal to minus EdL. Sometimes we also write this formula in this format. Moving to next question. Oh wow. Two charged spherical conductor of radius R1 and R2 are connected by wire. Okay, then the ratio of surface charge density of sphere sigma 1 by sigma 2 will be what? So we have to find out here the ratio of surface charge density. And if we are talking about a sphere, so the charge distribution will be per unit area. So we all know sigma will be equal to charge distributed per unit area. Okay, so this is the question here. Two charge, very easy question, I got the answer. Now this is your turn. Yes, at B, because if we further move potential, yes, correct. Yes, who can give me correct answer for this question? Yes, I'm waiting from you all. Very easy question, let me tell you, very easy question. Two charge spherical conductor. Yes, please do it. Anyone from you? Abdul Rashid? Please read the question carefully. Please read the question first, calmly. Yes, anyone? Q sigma into area R square by R1 square. Q sigma into area. What you are writing, so I'm not getting it. Okay, let's solve the question. Please look at here on the screen, please. If you are having problem in solving questions still, please at least you can see on screen. or you can take a screenshot how I'm solving the question. R2 square, good afternoon, hi Lohit, good afternoon, Abdul Rashid, B1 R2 square, sus, okay, just wait a little while. Okay, let's do. Two charged spherical conductor of radius R1 means we have one sphere here of R1 radius and one more sphere is of R2 radius, right? And both the spheres are connected with a wire, conducting wire connected by a wire. So let's connect this wire. Do you know what is the concept of this here connecting wire? As you will connect some conducting wire or wire to both charged spherical conductors, so what will happen? The potential of both will be equal with each other. There will be equilibrium of potential. Potential of this and potential of this will be same. Yes, my dear champion. So after connecting the wire, the potential of one and potential of two will be equal to each other. This is the concept. Please keep it in mind. When we connect a wire to a conducting spherical body or any conducting body, the potential of both the body will be equal to each other due to the equal charge distribution and the radius here. Okay. So V1 we can write here K Q1. Okay, let's say I'm taking charge Q1 and divided by R1 is equal to here K. Let's say charge is Q2 and divided by radius R2. So can we please cancel this? And this will be Q1 divided by Q2. Q1 divided by R1 will go there. So this will be equal to R1 by R2. Please keep it as it is. Now go here. We have to find out here the ratio of charge densities of the sphere. Oh my God. So sigma divided by sigma 2. Sigma 1 will be what? Charge distribution. Q1 divided by area 4 pi R1 square. We all know this is a spherical body, so the area will be 4 pi R square. And for sigma 2, this will be Q2 divided by 4 pi R2 square. I hope this is clear to you. Now can we please cancel here, whatever cancelling. So 4 pi will cancel here, and this will be Q1 divided by Q2. R2 will go there. So R2 divided by R1 whole square. Now can you see here, this is Q1 by Q2 and Q1 by Q2 we have already proved is equal to R1 by R2. So we can replace there. So we can put here R1 by R2 which is equal to R2 square divided by R1 square. Can we please cancel here? R1 will cancel this R1, R2 will cancel this R2. So this we are getting here R2 divided by R1. Any option is there? R2 divided by R1. Option number 2 will be correct. Option number 2 will be correct. Who answered me option number B? Option number B, a lot of students. Abdul Rashid, Tanmay is there. Lohit is there. Very good. Very good. Option number B is correct. R2, we are writing here R2. Where is the answer? So sigma 1 divided by sigma 2 is equal to R2 divided by R1. This is the correct answer. Option number 2 will be correct. Any problem to anyone? Is it clear to all? Is it clear to all? Moving to next question. 4 electric charges plus Q, minus Q and minus Q are placed at the corners of a square of side 2L. The electric potential. It means only algebraically addition. No vector resolution will be there. Why? Because the potential is itself scalar quantity. So you don't require to solve it using any vector format. So what will be the potential at point A? The midway between. Okay. So we have to find out here potential at this point due to all the charges. So very easy question. So to find out potential, we all know the potential, the formula of potential is equal to KQ by R. So we should have this R. R is the distance from the charge. R is what? This R. R is what, my dear champion? Distance from charge. So we have to find out that first. What will be the distance from all the charges? So if we talk about this plus Q, so this distance will be equal to, what is the square of side? Side of square. The side of square is 2L. So this half will be L. This will be L from plus Q charge. If we talk about this plus Q charge, so again for this will be L. And if we talk about this charge, so this will be the distance. And for this charge, this will be the distance. So we have to calculate that first. And we all know this is 90 degree and here is also 90 degree. Now can we please apply here Pythagoras theorem? This is 2L and here is also this is 2L. So can we please apply Pythagoras theorem? So if we apply here Pythagoras theorem, so the after apply Pythagoras theorem, I think the distance will be is equal to under root L 2L square plus L square, and this will be equal to under root 5L. 2L square is 4L square and L square is L square, so 5L square, so under root 5L. So this is, we have root 5L and this is also root 5L. I hope this is clear to you all. Now apply formula. So potential V net will be equal to K for this charge, KQ divided by L. Now for this charge plus KQ divided by L. Now for this charge, so this is equal to K, but charge is negative, minus Q, and what will be the distance? Under root 5L, Now plus for this charge, again negative charge is there, so K minus Q divided by under root 5L. What we can take common here? I think K Q divided by L will be common, so this is 1 plus 1 and here minus 1 by root 5, right, and this is also plus minus 1 by root 5, right. So this is equal to K Q divided by L, and 1 plus 1 will be 2, and this is minus 1 by root 5, minus 1 by root 5. Can you see here? Minus 1 by root 5, minus 1 by root 5. This will be equal to minus 2 by root 5. Right. Now K can be replaced by 1 by 4 pi epsilon naught Q divided by L, and we can take 2 common here. So after taking 2 common, 1 minus 1 by root 5. Now can we solve here? This 2 will cancel this. So the answer is 1 by 2 pi epsilon naught, and this is Q here and this is L here, and under bracket will be 1 minus under root 5. This is the answer. Can we please check it here? Q by 2 pi epsilon naught, Q by, and 2 is also there, no? This 2. Okay, we are taking 2, so don't erase this 2, don't cancel this 2, keep it as it is, because all the options are in the form of 4 pi epsilon naught, so keep it as it is. So this is 2, and here this will also be there, 4 pi. Now please check out the options here. You don't need to cancel that. So 2Q divided by 4 epsilon naught, 2Q divided by 4 pi epsilon naught L, under bracket 1 minus root 5. So option number C will be correct. So this is all about the distance. If you are calculating here potential, so electric potential, you don't require to solve it vector, use vector, no need of vector, because electric potential is a scalar quantity. This electric potential is scalar, so only algebraically add, simple. So due to all charges, this is potential due to this charge, this is potential due to this charge, this is potential due to this charge, and this is potential due to this charge. So we can directly add Kishan Godam. Kishan, you are giving option number, you are giving option number B. How is it possible? I think you responded for previous question, right? Maybe, yeah. Okay, moving to next question. What is the flux through a cube of side A if a point charge of Q is at one side of the corner? A very important question, but very logical question. If you have clear concept of Gauss law, if you know the Gauss law well, you can solve this question. Do you know Gauss law? So this question is based on Gauss law. So according to Gauss law, the flux linked with any charge or any charged body is equal to the charge enclosed in Gaussian surface, which is hypothetical. We all know the charge should be enclosed, and that in, yes sir, other color to write. Okay, sure, yellow color is good. So in this question we have to calculate the flux, and there is a charge kept at one corner of a cube. It means that this is a cube here, please focus on this question. This question is from the year 2012. There is a cube and one charge is kept here at one corner, and we want to calculate the flux due to this. We all know to apply Gauss law, we all know the charge must be enclosed. The charge must be enclosed, or we can say covered. Enclosed. The charge must be enclosed. But here the charge is now open. We have to enclose that. We'll have to enclose this charge, cover this charge. The charge must be enclosed. And how we can enclose this charge? So to enclose this charge, we required 8 cubes. Yes, my dear champion, just imagine. One cube is here. If we put here, this side one cube, this side one cube, one here, one there. So if we take 8 cubes, we required how many cubes, champions? 8 cubes. Yes, my dear. Then this charge will appear at the center of a bigger cube. Larger cube will be there, because we are arranging 8 more cubes. So if we arrange 8 more cubes to cover this charge completely, so this charge will be at the center of the bigger cube. Can you please imagine? Just imagine, I'm having 8, you all play Ludo. You all know there is a dice having number 1, 2, 3, 4, 5, 6. So if you keep 8 dices in this format to make a single dice, a bigger dice, just imagine this corner will be at the center if you place other cubes from this side. So what will be flux? By Gauss law, we all know flux is equal to charge enclosed, which is Q, divided by epsilon naught. But how many cubes are required to cover this? 8 cube. So we have to divide it by 8, 1 by 8. So the net flux will be equal to Q divided by 8 epsilon naught. This is the answer, champion. Can we see any option is there? Any option is there? Option number B will be correct for this question. I hope this is clear to you all. Yes, tell me. Anyone? If anyone is still confused in this particular concept, I can repeat this concept again for you, because this is very important. We required 8 cubes to cover this charge, right? So there will be a bigger cube, larger cube. I hope this is clear to everyone. Is it clear? Now applying Gauss law, we can get the answer. Okay, moving to next. So these are the important questions for today's session, today's live class. Thank you so much for coming in this live class today, everyone. And you all are so close to your NEET exam. Today is 27 and 3rd May is your exam. So if you may have any problem in any particular concept, if you want numerical on any particular concept, sir, do these questions. We are having a lot of issues in this question, in this particular concept. So you can put your query, your problem in comment section. I'll be looking out your query, and I'll be giving you definitely the solution for all those problems that you all are having right now in this crucial phase of time, right? So you don't panic, don't hesitate, and stay focused, stay calm, and some very important thing, please believe in yourself, right? So thank you so much for coming in the live class, and let's meet in the next session. Thank you so much. Till then, bye-bye.